Hello and welcome back to the Aimless Electron. I'm going to try something new for this episode. I'm going to start a new segment that I'm calling CodeBits. Instead of just the normal approach of showing you the hardware and some software, these are going to focus more on the code that goes behind a lot of the hardware and maybe some of the code that I'm just writing for the computer, anything along those lines that's just to do with code. So please sit back and I'll try to make this a little more enjoyable than most code videos. I know they're a little bit boring, so I'll try to keep it upbeat and quick. For this first episode, we're going to take a look at how to write to the Flash in an XMega. And I know that can be a real pain, so hopefully this will guide everybody through who's been going around looking on how to do things. And I'll include some links on the different documents that I went through to get this up and running. So stick around and let's continue and look at the code. On to the fun stuff. This code is a continuation on the DIY Reflow Oven project, so that's where I'm getting this from. The debugging that we're doing is going to be through printf methods, which are already hooked up to the standard output, in this case being USB to serial port supported by this code itself. I would like to make one more point that this is specifically for the XMega. For the other AVR controllers, writing to Flash may be a little bit different and you can use some of the stuff that's already out there a little bit easier. The first thing I want to show you is the assembly file, and it contains all the code that's necessary to actually read and write from the Flash page, including some of the other areas in Flash like the signature bytes or the boot sector. This is pulled from another website and slightly modified by me. One of the first things that I changed was to add this header file for the Flash page itself. And understand that Flash is written in pages, not individual bytes or words, even though it is stored in words, and I'll explain that in a little bit. So you have to define the actual page size for the rest of it and where it's supposed to start for things like the app table. If you don't know what the app table is, take a look at it. It's just a section that's specifically set up to write user or runtime values into Flash. Back to the assembly. The next section you'll see here is the non-volatile memory commands and the control bits, so that you're enabling certain things like self-program memory and IO register stuff. I'm not going to go over all of these assembly methods. I'm just going to go to the ones that are important to us, specifically this load Flash page and read Flash page. There's one other I'll hit up in just a second here, but first let me explain. Load Flash page takes an array or a chunk of SRAM and puts it into the Flash page buffer. That is what is used by the microcontroller to write to Flash itself. This method has to be inside of the boot sector. Again, I'll go over a little more of this as soon as I get through what this chunk of assembly actually does. It's pretty simple. It loads into the X register the address, which is coming in through R25 and R24, your array that you want to store. It sets what command you want to use for the non-volatile memory. It sets a loop to go through. This is kind of like just a counter. And the reason it's the Flash page divided by 2 is because we're writing words, not bytes. So if we have 256 bytes, then we're going to write 128 words. Finally, this is the loop that stores it into the Flash page itself. And that's it. That's all this does. When you're reading it, it's the same process, except that you're just pulling it out of the registers and storing it into your array instead of the other way around. The final one that we want to look at is erase write application page. All this does is call the command that erases and writes that Flash page into a specific location in your Flash in one go. While you can read from Flash just fine by calling it from anywhere, to write to it you have to call this SPM command, and to do that it has to reside inside of the bootloader section inside Flash. Well, to set that up you have to first put this section directive inside of your assembly code, and you also have to set aside a section for the bootloader. So if you go to properties for your project, go to memory settings, you have to add in a setting into your Flash segment, something along the lines of this. The documentation will say you have to put it at 20000, but the linker actually changes this from a word count to a byte count, so it doubles this, and it becomes 20000, even though it's only 1000 here. Make sure you have this or your code just won't work. Next I want to take a look at the C code that we have for the SP_driver. There were a bunch of functions in here, but the only two that I really needed were this atomic erase write app table or app table page function and this read flash page. This writes the flash, first erasing it, and this reads from the flash. And it takes in the page number, calculates the address from that and the flash size, and then either erases and writes or reads. The only other thing that this does is just wait for that erase write to be done, so it's kind of like a blocking call. Really simple functions, and they just call the appropriate assembly code. The other thing you'll notice here again is that flash page. The header file for sp_driver just has the declarations for all of those methods inside of the assembly part, and I also added the declarations for the two methods inside of the C file. Finally, I wanted to give you a quick look at the code I used to test this all out, and if you wanted to try it, these are a couple ways you can use it as well. I'll make sure I post this code, by the way, in GitHub and share the link in the description. I wanted to take a look at what we're using in the DIY Reflow Oven project, because this is kind of an extension of that series in itself. If you've been following along, you may notice that I have some new code inside the program's main while loop. And what it does is check for a flag to be set to true and then call this flash test method, which actually reads and writes the flash, or writes and reads the flash, to be more correct. The reason that it is set up inside the main for loop or main while loop instead of its own method called from the interrupt handler is because you can't call some of these methods from the interrupt handler. It'll just lock up your processor and then you're dead in the water. Let's take a look real quick at this flash test method, because that's the real test I've been running and what I'm going over right now. The first thing I want to point out about it is it makes use of these two arrays, which are just unsigned byte arrays of size flash page size. In this case, for the XMega 128, it's 256 bytes. For now, I just want to run through this method. From what I understand, you can only have 16 pages, so I check first to make sure the pages to write are set to 16. Now that may or may not be true, you might be able to do more. I will look into that later. For now I'm going with the safe bet of 16. I also use printf here that's attached to the serial out so I can do some debugging and actually see the results. This is made possible by the USB to serial link that I set up. So if you don't have that running in your code, you're going to have to find some other way to debug it or check to see if your results are actually there. And I'll show you another way to do that at the end. To go through this, the for loop is just counting down how many pages we want to write to, starting with page 0 and going up to however many pages minus 1. This mem set just makes sure our read buffer is clear, and then we fill our write buffer with 256 bytes. Right now, as you can see, I'm just using the I index, so really it's just putting 0 through 255 in this buffer, and you can put whatever you want in there as long as it's a byte value. Next we call sp load flash page, which is actually a call to the assembly itself. It takes in that write buffer and writes it to something called the flash page buffer. This next method call is actually what I'd call an atomic method, because it does the erase and the write at the same time. There's actually a version where you can do the erase separately and the write separately. In this situation, if you did not do an erase, because everything's already set to 1 when you're starting off, when you write to it, you're actually setting things to 0. So if you overwrite something without erasing it first, which again sets it back to all 1s, the bit values to all 1s, you're kind of doing a logical AND. So any 0 that you write will remove a 1, but any 1 that you write will be ignored because you're not actually writing 1s, you're only writing 0s. Finally, I'm just reading back the flash page, and I enter the page here with whatever's in this index P, and it puts it into a read buffer. The read buffer again is just an array of 256 bytes. Finally, I print it out for me to see it on the screen, and then when it goes through all the loops of the pages, it print out done. I wanted to point out real quick that this method gets called when we set that flag, and that flag is actually set right here. This is the event handler or the interrupt handler for my receive on the USB port, which is of course a serial port, and that's where this do flash test flag is set. Let me demonstrate that real quick. Back over here at our terminal window, I'm just going to press enter, and it's going to run through 3 pages of writing, then reading back. And that's what this looks like. If you scroll through this, we'll just stick to page 2, which is 0 index. This is actually page 3. You can see that the write buffer, starting at 0, was fed 0 through 255, if I scroll down here. And then the read buffer read back 0 through 255. That's how we know it worked. The final trick I wanted to share with you to actually verify that you wrote out bytes and not words and skipped bytes or something like that, and made sure the addresses that you were writing to for the pages were consecutive and contiguous. In other words, they didn't have chunks of places inside that you didn't write to, is to actually read the flash. So if you just go up to your project or your tool and device programming, make sure you have it selected, read the memories, read the flash. I'm going to save it to a document that I already have. Sometimes this doesn't work, but it might just be my crappy, knockoff programmer. Anyways, if I open this up inside of Notepad, reload the file, I can see that at my starting address before it, everything else is just all ones, all FFFFF. At the starting address in this case, you can see it start to count up from 0 all the way to FF, all 256 addresses. And it does it 3 times. That's the best way to verify they actually got information in. To wrap things up, I want to mention that a lot of the code I got was from links on the avrfreaks.net website from people who had done a lot of the hard legwork for this. Now, there may be things you have to modify, and I did have to modify some things as well, but these are the originals, and I'll make sure I link these in the description at the end of my video. Also, check out this document, which I will link as well, because it really ties things together and gives you a better understanding. If you liked this segment, let me know. Let me know if I should do some more code bits, and you'll see things like from C# and maybe even some SQL depending on where this goes. If you like the channel, subscribe to it. Don't hesitate to ask questions or ask me to see more information about this, or just leave me a general comment. In any case, I'll see you in the next one.